Hello everyone, today we are going to go through number of good pairs where we are supposed to receive as input an array of names and then we are supposed to find out how many of them are actually good pair. And a good pair is actually formed by two distant index elements having the same value. So let us take this one for instance. You have the element at position 0 which is equal to element at position 3. So this is a valid pair. You have element at position 0 which is equal to element at position 4. This is another valid pair. You have element at position 3 which is equal to element at position 4. This is another valid pair. So basically, how are we supposed to compute this? We are aware of what we want. Now, how are we going to solve it? So for us to solve it, I'm going to dive into a kind of visualization of the thing. So we are going to come up with a nice approach. So let us take this array for instance, right? You have this number of elements. Like we said, this one is forming a pair with this one. This is the first pair, right? This one is also forming a pair with this one. This is the second pair. And this one is forming a pair with this one. This is the third pair forming with 1s. And then lastly, this one is forming a pair with no one because there is no other 2. This one is indeed forming a pair with this one. So this is the third. So this is the first, the second, the third, and the fourth. So the first element, let's say we are in a situation where we have let's say 3 occurrence of 1, right? The first occurrence of 1 is going to form 2 pair. The second occurrence is going to form 1 pair, and the last one is going to form no pair, right? So let's say that means if you have 3 pair, that means this will lead us to 2 occurrence first, which is the number of occurrence formed by the first one, plus 1, which is the number of occurrence formed by the second one, and the third one will do nothing. The same here we have 4 pair, right? Since we have 4 pair, that means the number of occurrence is actually 4. That is the number of occurrence. That means the first one is going to make 3 pair. So the first one is going to make 3. The second one is going to make 2, and the third one is going to make 1. Can you see the pattern? So depending the number of occurrence, the first one is going to make the number of occurrence minus 1 because it needs to be different, like E and G need to be different. So the first one can make the number of occurrence minus 1. The second one can make the number of occurrence minus 2, and so on to the end. So now that we have a given pattern on how we can compute it, what will be our approach of solving this? So my approach will be as follows. Since I already know that there's a relation in between the number of pair and then the number of occurrence and the number of pair they can form, I will start by computing the number of pair. So that's what I'm doing here. I'm creating an under map, and then I'm looping through each of the element, and then I increment the number of occurrence. So at the end of this, I'll have something like this. So I'll have a map saying, let me change the color. Let me keep the same thing but different color. Let me take even this color. So after looping this, I will have a map like this saying that okay, we have 1 appearing 3 times, we have 2 appearing 1 time, and then we have 3 appearing 2 times. Nice. So the goal of my first loop is to have something like this. So once I have something like this, now I can loop through my map, and for each of the value, I can compute the number of pairs that can form with this element, right? So the solution will be as follows. So I will loop through my map, and then for each element in my map, it.second is actually the value. So when I will loop in, this is it.second, it.second, it.second is actually the value in the C++ map. Now that I'm taking the value, I need to compute the number of pairs that can form with this value. Here I'm going to use an arithmetical formula because I know that the number of pairs is actually equal to the sum of the n minus 1 element. Like we just said, if you have 4 pairs, we are going to form, the first one is going to form 3, the second one 2, and the last one, the third one 1, the last one 0. So basically, if you have n element, if you have n, so it's going to form n minus 1 plus n minus 2 plus tag until plus 1. So basically this is the formula that you are going to use. This is the formula we have. So if the value is n, this is the number of pair we can form, and this actually is the sum of the n minus 1 first element that can be achieved with arithmetical formula, this formula. So by doing so, I'm computing the occurrence of the number of pairs that can be formed with each of the element in my map, and I'm keeping increasing that to the result, and at the end I will return the result. So basically this was my approach of solving this. I hope you enjoy it. Let's just run so if you can see. We are going to see how the thing is performing, and you can tell by the performance that the actual solution is actually not bad. We have something interesting. This is my approach of solving this. I hope you do enjoy it. I'm going to give you a simulation as usual so you can have a better visualization if you need on how the thing is working. Don't forget to like, subscribe, and share, and see you tomorrow with a new video. Ciao.